Hello everybody. How are you doing? Thank you for joining us today. So my name's Elton. I'm going to be talking you through an introduction to Kubernetes with some workshop content that you can kind of work through yourself. This is all thanks to Linux in London, who are organising it all, and I will pass you over to Brian shortly to do an overview about what we're talking about today. I should set some expectations. So Kubernetes is a very large topic, and in the 30 minutes that we're going to be walking through it, you are not going to become an expert. But what my goal here is to introduce the main features of Kubernetes, the bits you use all the time when you start using it, to talk a little bit about what Kubernetes can do for you. So a little bit about what the features are and how it works for you why it's so popular, and to give you a feel of how you operate this thing. So when I come to the demos and the bits you can follow on yourself, you're going to be seeing how you interact with Kubernetes, how you define your applications so they run in Kubernetes, give you an idea of the key components that you're going to put together, and really just give you a feel for it, give you an introduction to it. The workshop part, it's very much going to be see how you get on, because all the content is going to be on GitHub, and you can follow along yourself. You don't need anything except some sort of Kubernetes instance, and I'll show you what some of the options are for running that. It's not going to be a guided workshop. It's going to be me going through a bunch of stuff, and you can follow along yourself if you want to join afterwards. Okay, so with that, what I'm going to do is I'm going to pass over to Brian, who runs the Linux in London meetup. He's going to walk through all the usual stuff with the sponsors and the code of conduct, and then I'll come back and we'll get on with the 101 presentation, and then moving on to the demos. So let me. So I should point out also that this is the first time I've done a stream where somebody else is joining in. So if I push the wrong buttons and we go into like an infinite loop of audio feedback, just bear with me a few seconds, and I'm sure we'll get it sorted out. Okay, so I'm going to hand over to Brian now. So let's push this. So sorry, Brian, but people can't hear you, so there's obviously an issue on my side. So I'm going to take back over the microphone. So sorry about that. Like I said, first time I've done this, so we're going to I'm going to switch back to my copy of the slides, which is a shame actually, because I could hear Brian, and Brian was giving me a really nice warm overview about how great I am. So I heard that, but nobody else did. So yeah, apologies. I don't know what happened here. So my recording stuff. It showed all the audio was bouncing up nicely. Everything looked great, but I can see in the comments that nobody could hear Brian. So I'm going to take over with that. Sorry about that, Brian. Next time we do it, we'll try and get this sorted out. So Brian was talking about Linux in London, which is this great meetup group that he runs. There's a picture of me. There are various sponsors for the group, so we heard about that with JetBrains and Tuxedo. There's a whole bunch of people sponsored it over the years. If you want to do some tweeting, then this is how you'll pick up the group. Education is the core thing, and Brian's really keen about involving as many people as possible. The main thing he wanted me to point out, which I completely forgot last time, is that there is a code of conduct. So that's the main thing here. So we're going to focus on that just for a second, let you read all that stuff out. And then, that if you ever go to the real in-person meetups, assuming we ever have any again, then this is the important stuff. And, it's all about being friendly to everyone else. Okay, cool. So, smiley face. Now I'm going back to my slide. So I'm sorry about that, Brian. Another week where you didn't actually get. Oh, there's your face is on the screen for a second. Let me go and show my slides. Okay, cool. So, welcome. So, my name's Elton. This is a very quick introduction to Kubernetes. The workshop part, I'm going to show you a whole bunch of stuff with a very simple application. It's actually the same application that we ran last week. So, if you joined in the Docker 101, we built this kind of basic bulletin board application that ran as a website that talked to a database. And they both ran in containers, and we ran them with Docker Compose, and we saw how to build them and all that sort of stuff. In today's session, we're going to take that application and we're going to run it in Kubernetes. But before we get there, we're going to just talk a little bit about what Kubernetes does and why it's so popular. Okay, so the stuff we did last week, taking an application and packaging it up to running Docker. You start with your Docker file, you do your Docker image build, you get this thing called an image. If you want to run your application in a container, then you do Docker container run, and that brings down all the pre-packaged components that your application needs. So in this example, it's my web application. Inside the container image, there's the base operating system, there's the node runtime, which my application uses, there's all the dependencies for my app, and then there's the application itself. And that all runs on my server, and that's all great. That's the kind of core thing about Docker. Kubernetes is another way of running Docker containers. And the reason why you need something like Kubernetes is that although Docker is super efficient, so I can have my server, I install Docker on it, I can run dozens of containers on a fairly modest server. I've only got one server. And if that server goes down, I lose all my applications. And if I have another server, so I've got a Windows example here because you can run Windows apps in containers as well. I've got the same thing. I've got two separate applications. If my app was a distributed app with different components talking to each other, they couldn't talk to each other through the containers, couldn't reach each other through DNS the way they normally would. So by having a single machine with Docker on it, you can run a bunch of containers, but you're limited to what you can do with those containers. And that's where orchestration comes in. If you've heard this term orchestration, it's really just about taking a whole bunch of machines. So I could have some Linux machines and some Windows machines. I install a container runtime on all of them. So it might be Docker, it might be something more lightweight like Containerd, which just has the capacity to run containers. It doesn't do the image building and all that sort of stuff. And I join them together in a cluster. And that's all Kubernetes effectively is. It's a bunch of machines that can all run containers, and they're all being managed by Kubernetes. So Kubernetes is like the management layer on top of all those things. So when you're dealing with applications in Kubernetes, you don't say, please run a container. You pass the information to Kubernetes and it decides where to run containers. So it's going to talk to the container engine on the servers, start containers, monitor them, make sure they're still running, all that sort of stuff. So you're no longer really interested in running individual containers. You're working at a higher level all the time. You describe your application in more abstract details, and then Kubernetes makes it real and concrete and creates the containers and manages them for you. So when you're actually dealing with Kubernetes, you can kind of forget that it's a cluster of servers, and you can kind of ignore the fact that there are all these machines that are actually running the containers under the hood. You just work at the level of the API, which Kubernetes gives you, the description language for modeling your application. And you do that and we'll see lots of these today, with YAML files. So YAML is this more expressive way of capturing information, which converts to and from JSON. So it's very easy for machines to work with, but you can put comments in there. So it's much nicer for humans to work with. It's a little bit easier to run. So when you're modeling your application to run in Kubernetes, you're going to have several components that you describe in this YAML format. And when you're ready to run it, you send those YAML files or that YAML file to the Kubernetes server, to the Kubernetes cluster. You send it to the API, and then it starts a bunch of containers for you. And those containers that are running within the cluster, it doesn't really matter what node they're on. Kubernetes kind of creates this virtual environment where it looks like everything is next to each other. So if these containers, if I need to spin them up, if I need to scale them up, Kubernetes takes care of that for me. It will run multiple instances. If these things need to talk to each other, then Kubernetes will direct the network traffic, traversing nodes, even if they're on different operating systems, all that sort of stuff. And it will let me model a distributed application and manage it all for me. And it also does other stuff too. So it manages containers, but it also manages other components which come in around the containers, because the container itself is not enough to be a whole application platform. You can manage the containers, you can run several instances, you can run them on different servers, and if a server goes down and takes some containers, then you start replacements. Kubernetes does all that stuff, but then you also need a way of managing traffic into your application. So Kubernetes has these other types of object that you define. You still define them all in your YAML files. You define these other types of object like a service, which listens for traffic coming into the cluster and directs it to a container which is going to fulfill the request that's coming in. And there are other objects too. So because you have this cluster of machines, Kubernetes also has this kind of clustered database. So you can store information about your application that your application can use. So configuration files can live centrally in Kubernetes. They can either be kind of plain text JSON files or XML files or whatever your application uses, or they can be secrets, which can be encrypted as part of the Kubernetes cluster, and they're delivered into your container when your container runs. So as part of modeling your application in those YAML files, you're going to say, here's the config file that I need. I'm going to store that in the cluster. My container here, it needs that config file, and please surface it into the container file system. And then Kubernetes moves all that stuff around for you. So it takes care of it more than just the containers. It takes care of all the pieces around it. Now, the diagram that you've just seen is a simplification, and before we go too much further, we're going to need to put real names on all those objects. So in the Kubernetes world, there are lots of levels of abstraction over and above the container. So ultimately, your app is running in a container. It's going to be using the same Docker images that you run locally on your laptop, or that you run with Docker Compose, or that you run with Docker Swarm. It's the same Docker image, but you're not running a container in Kubernetes. Kubernetes manages them for you, and every container lives inside this thing called a pod. And a pod is just an abstraction that lets Kubernetes manage the container for you. So if you think about, and we'll see this in the demo, if you think about running a container, the container is only alive as long as the application in the container is still running. If that application dies, the container dies, and depending on how you're running it, that might be it. If a container exits, then Docker just leaves it. Because it's wrapped up in a pod, Kubernetes is watching the pod, and if the container dies, it will restart it. So it's a management level on top of your container. So pods can run your different applications in containers, and you can have multiple copies of your pod. So the pod itself is managed by another object, which and there are different options for this, but the most common one is called a replica set. And a replica set lets you say, I want to have 2 instances of my application. So in the kind of lowest level, I'm saying my web application, my Node.js application, I want to have 2 copies of that running somewhere on the cluster. But in order to manage that, each of those containers will be in its own pod, and the pods themselves will be managed by the replica set. And the replica set is going to say there should always be 2 pods running across the cluster. I'm going to make sure there always are. So if a server goes down, I can bring up a replacement pod. And then the pods themselves are responsible for looking after the container. So if my pod is running happily on a node, but the container fails, the pod will restart it. So there's these abstractions that build up on top of it. They add to the complexity, but they increase the power of what Kubernetes can do. And replica sets themselves are managed by another object, typically. So there are different ways you can use this stuff. But what I want to introduce you to is the typical way that people are deploying applications. So you define this thing called a deployment. In the deployment, you say you're going to run a replica set. The replica set, you say, I want to have 2 copies, and this is the pod I want you to run. So we're going to see all these when we get to the YAML files, and it'll all start to kind of click. But I wanted to show you in advance that Kubernetes is a big topic, and the things we're seeing in this diagram are really the kind of basics that you need in order to be able to use it effectively at all. Okay, so this is the application runtime. This is the compute side of it. It's running the apps in containers. It's managing them with these other objects to give you the high availability and the ability to scale and the load and all that sort of stuff. Then there are other concerns that Kubernetes deals with, like configuration. So I can create these objects called secrets that live inside the cluster, and I can deliver them to my containers through the pod definition again, through the pod specification that says the container in this pod needs to have access to this secret, which should already exist in the system. So it manages the application configuration as well as the compute of the runtime. And then there's also networking. So all these containers that are running in pods, they can all access each other across the whole cluster. Each pod has its own IP address, and the pods could talk to each other over the IP address. Doesn't matter if they're on different servers, if the servers are running different operating systems. That as far as Kubernetes is concerned, it's got a flat networking plane, and everything can reach each other by IP address. But of course, if a pod dies and a replacement starts up, then it'll have a different IP address. So Kubernetes has a DNS server built in, and you can use the DNS server for pods to reach each other. And the way you do that is with this other object called a service. So the goal of the service is to be a DNS name, and the DNS name which will ultimately go and send some traffic into a pod. So if my web application needs to talk to a database, the database will have its own service, which gives it a DNS name. And inside my pod, when I make my connection to my database, I'm going to use the service name. When the traffic hits Kubernetes, it will direct it to the pod that's actually listening for that service. So the service it decouples the networking layer from the compute layer, which means it doesn't matter if the pods change. The service still has the same IP address and people can still use that. It doesn't matter if there are multiple pods that are providing the application, because the service can load balance between them. So it's another decoupling effort, which just makes life a lot easier for structuring complex applications. There are different types of service. Some are internal to the cluster. So that means, I've got an internal component in my distributed application. I only need to use it from other pods, so the service isn't available publicly. And then there are also kind of public services where Kubernetes listens for traffic coming into the cluster. It still goes to a service, which is an abstraction over my compute layer, and then Kubernetes works out where to send it to the actual pods. So complicated diagram, seeing as we're only a few minutes into the Kubernetes journey, but these are the main things that you need to understand. They're the terms you will come across almost immediately when you start using Kubernetes. And by starting off with them, you're gonna kind of get experience to them pretty quickly. By the end of the kind of workshopy bit, by the end of the demos, you will be using all these things, and you'll see how they all fit together, and you'll see what the benefit you get from Kubernetes, layering on these abstractions on top of the basic stuff, on top of the basic container. Having the pod and then the replica set and then the deployment means you have a much more powerful way of working with this stuff. Okay, and this is a very kind of abbreviated version of some of the YAML that you will use to describe your application. So I talked about services and deployments. Here's kind of roughly what they look like. There's more information that you need to put in, but this is the basic stuff. So it's not as complicated as you might think when you first start looking at this, because a lot of it is boilerplate code. At the top half of this screen, I'm saying I want to define a service, and the type of service is going to be a load balancer. And all that means is that Kubernetes will integrate with wherever I'm running my application platform, whether I'm running in the cloud or on a laptop, and it will listen for external traffic coming into the cluster, and it will direct it to some pod or some set of pods. And this is just saying I'm listening on port 8081. I'm going to send it into a container on port 80. There's a few more bits and pieces that are always part of a YAML manifest, but that's the kind of basic information for your service. And then the deployment, which is the second half, I'm just saying, look, this is the container image I want to use, which is my Node.js application that we built last week. That's the image I want to use. There's going to be one replica, and it's going to run somewhere in the cluster. I don't know where it's going to run. I don't need to care. It's Kubernetes' job to find a node that can run that application, run it create the pod, create the container inside the pod, and make sure everything stays up. And if there's any problems with it, then Kubernetes is going to deal with scheduling a replacement pod to run on some other machine to make sure I've always got the service level I've requested, which is in that replicas field. So I've asked for a replica of one pod will run somewhere, and Kubernetes will make sure that that pod kind of carries on running. Okay, and that's your introduction. Now I'm going to move on to a bunch of demos. If you have a Kubernetes instance that you can play with, and I'll show you some examples of where you can get like a development lab up and running pretty quickly, then you can follow along with this URL, which is good slash, it looks like Synivi or Synivi, and that's going to take you to a GitHub repo. And the GitHub repo is here. I've got my local copy here. And it's just, there's a README file with a whole bunch of steps in it. And I'm going to go through that. I'm going to show you through all the YAML files. And you can take the beauty of Kubernetes is that when you've mastered the the object API, when you've mastered the YAML the YAML language that you use, that's super portable. Like you can take, when you understand how services and deployments and replica sets and pods and all the other stuff like persistent volume claims and everything else fit together, then you can run the exact same application on your laptop as you can on a 50 node cluster in Azure. Like you don't need to change the YAML at all. You use exactly the same thing in each of your environments. Your application might behave slightly differently, but that's just down to the configuration files, which are different for each environment. They get loaded into the cluster and presented to the application. So it's this really super portable way of moving things around, which is why people love it, because if you want to move your applications from the data center to the cloud, if you move to Kubernetes first, you're not limited to one particular cloud. Like you can take that anywhere. And from a human perspective, if you've kind of mastered Kubernetes, it makes you super portable, because you can join any project where they're using Kubernetes and they'll go like, here's the README file, here's all the YAML files, and you'll be up and running in practically 0 time. You don't need to understand what the application itself does on day one, but you can run it straight away because it's being modeled in Kubernetes YAML files, and you'll understand all the objects and how they fit together. Okay, so that's the disclaimer about why this stuff's so complicated. The README file here, there's 3 links. This is the link to the docs themselves. These are the slides that I've just been through, and this is the video which you are either watching now. If you're watching it now, then you know this URL. This is the URL where the video will live afterwards as well. So you can see this at any point in the future. Okay, so you need to have a Kubernetes cluster if you want to try along with this. It can be a single node cluster, and there are some really good development instances where you can use for that. So Docker Desktop is one of them. That's just for Mac and Windows. So if you're a hardcore Linux user, you're not going to use Docker Desktop, but it is probably the easiest way to get started with Kubernetes, because it gives you Docker, Kubernetes, and manages it all for you. It's super easy. If you're a Linux user, then Kind is probably the best option. Kind is short for Kubernetes in Docker. So you install Docker first, and then you run Kind, and then you can do things like, where are we down here? Kind create cluster, and it will create you a cluster. It runs inside Docker. It manages it for you, but it's a super easy way to get up and running if you're on Linux. And then there are some online options. So there's Play with Kubernetes, which is similar to Play with Docker that you might have seen last week if you joined in with the session last week. It's an online Kubernetes playground. You need to log in with a Docker ID. You click start and it gives you access to an online Kubernetes cluster. I would be using that today, but it didn't work when I tried earlier, so I'm going to use my local machine instead. The other option for online is Katacoda, which has a similar approach. It's an online playground. If you click this button and then click this button, it'll create a Kubernetes cluster for you. The trouble with this particular option is that it's got a really old version of Kubernetes. So it's running Kubernetes 1.14, which is a pretty we're in 1.18 now, and there are some things that are a bit different. So I'm going to use Docker Desktop that I've got running locally, but you can use these other options if you don't have anything that you can work with. Okay, so then you need to clone this repo, which is what this bit here is, and then switch to the directory where all the YAML files are. So when I'm working here, these are the YAML files. That's the README. And these are the various YAML files that we're going to go through, and you can break up your Kubernetes definition. So I'm using a different YAML file for each object. So my service is in one YAML file, my web application in another, and we will see all those as we go through. Okay, so the first thing I'm going to do is a really simple, kind of boring demo with an application that doesn't do anything. So this application here, which is called Sleep, it's a deployment. So all Kubernetes manifests kind of start in the same way. They start with an API version, which is a versioning scheme that Kubernetes uses for its schema, and a kind, which is the kind of object you were defining. So this is a deployment object, and that lives in this apps/v1 namespace. Kubernetes, there's so many objects in Kubernetes that everything is kind of broken into namespaces to make it kind of easier to work with. Okay, so everything starts with that. And then there's some metadata. And the metadata is the name of the object. So when I create this, I'm going to have an object, which is a deployment with the name Sleep. And then the labels are arbitrary kind of key value pairs that you can apply to do different things. You can use them as a human to make it easier to manage your objects, and Kubernetes itself uses them. So the top level here, the metadata, is just information about the deployment. And then the spec is the specification of the deployment itself. So remember, the deployment object is the thing that ultimately will create my pods for me. And the pods here are going to be using this pod specification, which is going to create a container in the pod. The container will be called Sleep, and the image is this KYML CH03 Sleep image. which is just a Linux I think it's Alpine Linux, and it just sleeps. It doesn't do anything at all. So it just sits there, which means you can connect to it and you can do other things to it. So that's the pod specification. The other stuff here are the labels that will be applied to the pod. So again, I've got this kind of arbitrary naming option that I've got. I'm calling this, I'm adding a label called app with the value sleep, which is going to filter down to all of my pods. So when the deployment creates these pods, the deployment itself will have a different label. The deployment will be labeled demo cube 101, and the pods will be labeled app sleep. And that's how, and the labeling is really important in Kubernetes because lots of aspects of Kubernetes use this idea of a label selector for resources to find other resources. So the deployment object, although ultimately it owns the pods that are going to be running, it doesn't have a kind of list that it maintains. It doesn't say I own pod 1 and pod 2 and pod 3. What it has is it has this selector, and it says when I'm looking for my dependent objects, when I'm looking for the pods that I own, I'm looking for any that have a label called app with the value sleep. And if that matches, then that's my pod. And that's this kind of loose coupling that Kubernetes uses all over the place. So even with a really simple thing, it's good to get the idea right early on that labels are kind of intrinsic to how Kubernetes works. You can use them yourself to make life easier. So my demo label will come into play right at the end, but the internal use of Kubernetes, labels are a key thing for objects to find other objects, to express a relationship between them. In this case, it's an owning relationship. So the deployment ultimately owns the pods. Okay, so that's a lot of talk to run what is effectively one container, which is not going to do anything at all. So let's go and run it and see what happens. So I've got my Kubernetes cluster running. So if I do kubectl get nodes, first of all, this is why I copy and paste everything. I've got a single node in my cluster. I'm running Docker desktop. It tells me the version, all that sort of stuff. It's just there's nothing running in my cluster at the moment. So if I deploy this, the way you interact with Kubernetes is with this command line tool called kubectl. If you install Docker Desktop, it gives you kubectl as well, so you don't need to worry about installing other things. If you're using Kind, the instructions will tell you that you need to download kubectl as well. The Kubernetes approach is you can create objects through kubectl. So I could do kubectl create, and I could tell it that I want it to create a pod or a deployment. But typically, you won't really ever do that unless you're trying to debug something. Typically, you define everything in your YAML file, and then you run kubectl apply. And what that does is your YAML file is the desired state. So Kubernetes will use by saying kubectl apply, it will send my YAML file to the API, the Kubernetes API. The API will say, okay, you're asking for a deployment called sleep. I don't have one, so I need to create one. And that's how this works. So the YAML is your desired state. When you send it to Kubernetes with the kubectl apply, Kubernetes will look at what's currently running in the cluster. It'll look at what you've asked it to run, and it will do whatever it needs to do to get up to your desired state. So in this case, it's going to create that deployment for me. So we'll see that here. So it's deployed an app. It's deployed my deployment called sleep. And then that itself is going to create my pods because the deployment owns the pods. So now if I do kubectl get pods, this is the pod that's been created by my deployment. So I can see here, if I look, it's only 13 seconds old, so it's just been created. It's got a kind of random name. The prefix is the same as my deployment name called sleep, but the rest of it is a kind of random mishmash. It's currently in the status running, which means it's all good. And it's got some labels applied. So there's my app equals sleep, which is what I defined inside my YAML manifest. And that's what the deployment is using to say, this is my pod. Okay, so that's up and running. Not doing very much at the moment. It's just kind of sat there. But the whole purpose of having a pod is that I've got these extra layers of management. I could just do a Docker container run using that same container image name, and I would have ultimately the same thing, a container sat there doing nothing, but I would have to manage it myself. Whereas now Kubernetes is managing it for me. So if I do a describe pod here, I'll get a bit more information. So the describe command is for humans. So it gives me a whole bunch of stuff which I can see. It's got the kind of setup of the pod. It's got all the internal details like the IP address of the pod, the labels that I've got in there, when it's been running, and a whole bunch of events that fired off. So I can see it's been scheduled to a particular node. I've only got one node, so that's the one it's running on. It's pulled the image. It's successfully pulled the image. It's created and started the container. So the describe command, you'll use it a lot just to see what's kind of going on, but it's not for automation because it just gives you this human readable format. Okay, so let's clear that down. What I now have is I have this pod running, and I can connect to it and run commands just like I would if I did Docker container exec to run a command. I can use kubectl exec. So what this will do is it'll run a command inside my pod. So I'm telling it that here's my deployment. It will go and find the pod for that deployment, and it's going to run the hostname command inside that pod, and it will send me back the results. And that's it. Like so that pod is running. It's running a command which just sleeps indefinitely. But because it's a live container, it's wrapped up in a pod, which is wrapped up in a deployment. I can access it in different ways with Kubernetes. And what this is doing is running a command inside the pod. The host name of the pod is actually the pod name. So I can just have a quick look at that and make sure that everything's kind of running as I expected. So that's all, like, I appreciate that's pretty boring, but the idea is it's going to give you a feeling for how you're working with this stuff. Even for the very simplest of simple things, I'm going to write my YAML file, I'm going to run kubectl apply to deploy everything inside the cluster, and then the cluster is going to manage this stuff for me. And I'm going to use the kubectl command line to interact with my application. So the next couple of things I'm going to show you will start to understand the benefit of having all these extra levels of complexity on top of my container. So if I run another command inside the container, if I run the kill command, that's going to kill all the applications, all the processes in my container, which basically will send the container into the exited status. So now if this was a Docker container and I was just running it on my machine and I did Docker container exec kill all, it would kill the sleep process. There is no more process in the container, so the container exits, and that would be the end. But because my container is wrapped in a pod, Kubernetes sees that my container has stopped, and what it's going to do is it's going to restart it. So I can see it's up and running, and it's been restarted once. So it's still the same pod that's been sat there for 3 minutes, but it's been restarted once now because the container failed. So the pod is a level of management on top of the container, which means that if there's a problem inside the container, I get this level of availability, which means it gets restarted for me. And then, of course, the pod itself is managed by another thing. And again, the payback for the complexity is that your life is made a lot easier when things don't go according to plan. So if my pod was to go missing, either because the node it was running on left the cluster, or the node went down, or something else happened, I can simulate that by deleting that pod. The -L at the end there, that's finding a pod by the label. So there could be any number of pods that I've got a random name for my pod. Rather than find this pod name and put that in the command, I can find the pod by the label. So any pods that match that are going to be deleted. So now Kubernetes deletes the pod, very nice. So now my container is gone, except that it isn't, because my pod is managed by a deployment. And that deployment has been told to always have at least exactly one replica of my pod up and running if it can. So what I've got now is another pod with exactly the same specification. So it was started with the same pod template that was in my YAML file. It's a different pod, so I've got a different random name. It's got the same prefix, but it's the suffix is different. And it's been running for 20 seconds and it's had no restarts. It's a different pod with the same application inside it. So that's your kind of first introduction. The YAML file defines all these extra levels of management on top of your container, on top of your compute layer, and then you interact with Kubernetes, sending your information to the API, and the API decides what it needs to do to make this stuff create. And then once it's created, it keeps it running for you. So I can delete the container, I can kill all the processes, I can delete the pod, and Kubernetes will just keep it up and running for me. Okay, so that's my sleep pod. Doesn't do anything useful, but we're going to do something slightly more useful now. So that pod's still running there. It's still running in the background. I'm going to run my web application from the last session, which is this Node.js bulletin board application. So I've got two YAML files that describe the web part of it. So the first part is my service. So this is a web application. It's publicly accessible. So I want when traffic hits my cluster on a particular port, I want it sent to my my pods that are running my web application. And that's what the service does for me here. So this service, again, YAML file starts in the same way. The API version is v1 in this case. The kind is service. That's the kind of object that I want to create. Let's go and have a look at the metadata. So the metadata is information about the service. So it has a name. That's important on a service because that becomes the DNS name. So even though that I want to use this application externally, so I want traffic coming into the cluster to be picked up by the service and sent onto my pod, if I have a service running, then it's also available internally within the cluster. So the DNS name bb-web will be available inside the cluster. Okay, so that's the metadata for the service. And then the specification just specifies the ports that I'm interested in. So I want you to listen on port 8080. So any traffic coming into the cluster on any node will be picked up by this service, and it will be sent on to one of the pods at the target port 8080. So the pods are listening on the same port too. Now, the pod that it's going to send it to will depend on a label selector. So just like the deployment uses a selector to find the pods that it owns, a service uses the same principle to find the pods where it might send traffic to. So the service itself doesn't have anything running. It's just a network layer. It doesn't have a container that does anything. It's just a bunch of IP routes effectively. And what this is doing is saying when the traffic comes in to my service, it's going to find a pod that matches that label and send the traffic onto that pod. So it doesn't matter where the pod's running on the cluster. It doesn't matter if there are several pods, because the service will load balance between them. So this selector decouples the networking layer from the compute layer. So it doesn't matter which node picks up the request. It can send it to a pod wherever that pod is. It doesn't matter if there are multiple pods on each node or multiple pods across the cluster. The service takes care of finding them and sending the traffic. And there are different types of service. So this service is a load balancer service, which is the bit, let's get rid of that screen, which is the bit that says, I want you to integrate with the platform to give me an external IP address. So if I were to deploy this in the cloud on an AKS cluster in Azure, I would get a public IP address when I deploy this service. And then the public IP address would be where I configure my DNS name in my public DNS. When I run it locally on Docker desktop, it's just going to use localhost because that's all I've got. But the load balancer type integrates with your platform to give you external access into your service. Okay, so that's my service. All that does is just the networking layer. And then if I'm also going to deploy my web application, which is here, and this is another deployment. So the same kind of thing that we've seen over and over again. For most applications, you're going to have, each component will have a service so things can find it, either within the cluster or externally, and a deployment which configures how it gets run. And this deployment is the kind of same thing we've seen before. I've got my, back here, I've got my API version and my kind to say this is a deployment object. I've got my metadata with my labels in there. And then just like before, I've got an image name, which is my bulletin board, which is my web application image. I've got the labels that get applied to the pod. And then I've got a selector for the deployment so it can find the pods that it owns. So again, when this runs, I'm going to have a single replica, one container running in one pod, which uses my Docker image, and it's going to be managed by my deployment for me. So these same patterns that we're seeing are the way you kind of run all your applications in Kubernetes. Okay, so when I deploy that, I've got both those YAML files in a single folder. And when you do kubectl apply, you can specify individual folders, individual files, multiple files with lots of the -f flags, or an entire folder. So what I can do here, if I do kubectl apply -f/web, it's gonna find the service and the web deployment YAML file, and it will deploy them both. Okay, and that's like, it's super fast. So it's created my service, which doesn't do anything. It's just networking. It's going to give me a DNS name and an IP address. And then it's created my deployment, which is going to create my pods. So the pods will ultimately respond to any requests that come in because the service will send traffic to them. So if I clear the screen down here and we have a look at what we've got running. So if I look at get service, so most of the Kubernetes objects have a full name like service. You can use the plural or the single, and most of them have a short name too. So I can do get SVC. It's going to show me the services. Now, the service that I've just created is my load balancer service here. So I'm into my little fancy thing that showed up. So my load balancer service is my BB web, and I've got a cluster IP address. So that's the IP address within the cluster. So other things, other components, other pods that are running in my cluster can use my DNS name if they want to contact my web application pods. And when they make a DNS lookup query, Kubernetes will pick up that DNS request and it will send back the IP address of the service. So the IP address of the service within the cluster is fixed. That won't change unless I delete the service and create a new one. So the pods can come and go. So as I'm deploying updates to my application, the way I'm going to roll out an update to my deployment is by using a new version of the image. So I'll get new pods with new IP addresses, but it doesn't matter because the service IP address is how things communicate with each other. So the actual individual pod IP address doesn't really matter. The service takes care of that. The external IP address is because this is a load balancer type of service. So that's gonna give me an external IP address, a real IP address in a cloud Kubernetes cluster. But when I'm running locally, it's just on localhost. Okay, so if I go and look at my pods, and we'll see what's running. There. Okay, I've got one pod and it's in status error. Okay, and it's restarted 4 times. So the ready column here is telling me that there should be one container in my pod and there are 0. So there's a problem with my pod, and the error is telling me that something's wrong and it's been restarted 4 times. So the restart tells me there's a problem at the container level. So the container is starting, it's exiting, and Kubernetes is restarting it and trying to fix whatever's wrong. And it doesn't know what's wrong. So all it does is it restarts it, and it'll just keep on trying to restart it. So it's been busy for the last 2 minutes, just restarting the container over and over again. If I look at the logs for my pod, copy the wrong thing there, sorry. This is my application log. So this is what's coming out of my application container when it tries to start. And actually, this is extremely unhelpful. But what it's telling me is there's a problem in my Node.js application. When it starts, it tries to connect to the database, and there is no database. All I've deployed so far is the web part of it. So it fails, the container dies, and then Kubernetes says, the pod says, well, my container's not running, so I'm going to restart it. And it'll just keep on doing that. And this is what you, bizarrely, this is what you want in a distributed application in a dynamic platform like Kubernetes. Like when the application starts, if it can't reach its dependencies, if it just exits, then the platform can try and do something about that. And what Kubernetes is going to do in this case, it's just going to keep restarting my container. So eventually, when my database does come online, when I deploy it in a moment, a new container, the container will be restarted. It will find the database and everything will just work. So Kubernetes is managing that stuff for me. It's going to keep restarting my failed container until it works, which it will do when the database comes online. Okay, so let's go and have a look at what's going on here. I'm going to leave my pod cycling in an error mode for the time being. I'm going to have a look at this service again. So my service has this cluster IP address, which is the internal IP address within the cluster. Even though I've said this is a load balancer service, so I want to connect the external world into my cluster with this service, I get a cluster IP too, so I can still use that within my cluster. Now, if I run a command in my sleep pod, which is still running, if anyone knows of a VS Code add-in, which lets you click something from a README document, from a markdown file, and put it into the terminal, that would make my life way easier, so please tell me. So I'm running a command in my sleep container, and the command is a DNS lookup. So this NS lookup tool, it lives inside my sleep container image. So I can do a DNS lookup for bb-web, which is the name of my service. And when I run that, I get the response back out here. So the response here is for the name bb-web, which is actually a short version of the full name, which is .default.service.cluster.local. That DNS name, which I can use with the short version, I get this IP address back, which is the service IP address. So ultimately, if I try and send traffic into my service, it's going to use the service IP address, and it will get routed to my pod using the operating system networking layer. So this is for the Linux people, this is VIP, this is virtual IP addressing. So this virtual IP address just exists, and it's kind of transparent how it gets mapped to the pod. I don't need to worry about that from an application level. I'm not having to put any code in my application to say, if I'm running in Kubernetes, I need to do this. It's just DNS names, IP addresses, standard TCP/IP networking. Okay, so I can try and talk to that service. So I can do the same thing here. If I clear this down, I'm going to run another command, same sleep container. I'm going to try and curl my web application. It's available locally because I've got my DNS service. But what I'm going to find here is this is just going to fail because the container isn't running. So the service still exists. So I've got my DNS lookup, I've got the IP address, but it can't route to the pod because the pod just keeps restarting. So the app isn't working now. Okay, so we've seen with that kind of demo so far, we've seen how the networking layer is separate from the compute layer. And you've got this loose coupling, which is all done with label selectors. And so my service receives the traffic and it's going to send it on to one of the pods that matches the label. Okay, but right now my app is broken, so I'm going to go and fix it. So my database component, and again, this is the same kind of simple app I ran last week. The database just runs in a SQL Server database in a Linux container. And I've got 3 components that I'm going to deploy to my cluster to give me what I need for my database. So the first one is a service. So this is not a public component. So I'm not making my SQL Server database available publicly. This is a cluster IP type of service, and what that means is it's only going to have a cluster IP address. I can only access this from pods within my cluster. The rest of the definition is very similar. So I've got a metadata. In the metadata, I've got a name, and that becomes the DNS name. I've got my label, which I'll use at the end of the demo to clear everything up. So I'm going to find everything that has that matching label and just delete it all. So my cluster's empty again. And then these are the ports that my application uses. So this is SQL Server. It uses port 1433. If I want to, I can map them differently. So I could publish port 1432 and send it into 1433. So that's the port that I'm using. I can do that for mapping. And then the selector is the bit that says I'm going to find the pods that have this label. So when I run my database, I need to make sure that my pods have the label app with the value bbdb, and then the service will find them and send traffic in. This service only gets used by the web application. So the web application, which is still spinning and still trying to connect to the database, it uses this as the DNS name for its database server. That's already in its configuration. So at the moment, it's keeping trying on looking for that address, and there's nothing there yet. But when this service is deployed and when the pod is available, then it will find my database. Okay, so that's my database service. That's just an internal cluster IP service. The database itself, it's just a deployment. So again, everything I'm going to run in Kubernetes, ultimately, it's a Docker container image. So this is my bulletin board database image that's already got my schema and everything ready to go. That's on Docker Hub. So again, Kubernetes just works like Docker does, and it's going to pull that image down if it doesn't have it on the node, and then it'll run my container and wrap it in a pod. The rest of the stuff is very similar. So I've got the labels that get applied to my pod. That's how the service will find it. And that's also how the deployment finds the pods to manage. And then I've got a few other bits and pieces in here. So my SQL Server image expects to have an environment variable set with the password for the admin account. And if you did watch last week, then you would have seen that lived inside in plain text inside my Docker Compose file, which is not very secure. But that's the best you can kind of do with Docker Compose, because Docker Compose just runs containers. It's not a cluster. It doesn't have a cluster-wide database. It doesn't have encryption and anything like that. What I can do with Kubernetes is I can say, I want this environment variable to be loaded from a different object, from a secret object. I'll create that object inside the cluster independently. So that secret is a separate type of Kubernetes resource. So I've got deployments, I've got services, I've got my secret. That secret will contain a value with this same key. And when I run this deployment, the pod will get started. The value of the secret will be read by Kubernetes, and it'll be surfaced inside my pod as an environment variable. So when I'm deploying this secret, different deployments of Kubernetes have different levels of security. Your secret might be encrypted in the database. It can be encrypted in transit. It's only stored in memory inside the container, so it's not written to disk in plain text kind of anywhere along the journey. And it's a separate object, so it has a separate level of management. So I can have one team deploying my secrets who have access to the plain text values, but the other teams can use them inside their pod, but they can't actually work with the secret objects themselves. So it's a separation of configuration, which means I can have different workflows for how I deploy the config for my application. In a real production application, I'd have a ton more configuration going in here. So I would have my Docker container image would just have the basic config for my app, and the rest of it would come from configuration files that live inside Kubernetes, either as secrets or as an alternative object called a config map, which works in the same way, but it's not encrypted. That's for kind of non-sensitive data, and the secret is for sensitive data. So the other thing I need to do, this pod won't start unless this secret exists. So I need to create my secret too, and I have a YAML file for that as well. So inside here, I've got my secret YAML file, and very similar to all the other things you'll see. So the definition, it's a secret. That is the object I'm creating. This is the name of the secret. This is how I'm going to clear it up afterwards. And this is the data. Now, this is in plain text. You can also use base64 encoding, which isn't encryption and it's not secure, but it's helpful if someone looks over your shoulder, they can't see the value. I'm just using plain text in here. How you work with secrets kind of depends on the workflow that you currently have and the workflow that you want to have. So what most people do is, if you've got an automated deployment process, inside here you'd have some kind of template. So you wouldn't have the actual value. You'd have some kind of marker inside there, and your YAML file would live inside your source code along with everything else. But when you come to deploy it, you would have something like secret I'd have some kind of marker in here, and your deployment process would say, find that YAML file, replace that token with the actual secret, which lives in, I don't know, it lives in Azure Key Vault, or it lives in a GitHub secret. So it's separate from where you are. The other workflow is if you've got a constrained environment, you might have a configuration team, and they would own the secrets and they would manually deploy them. So once they're inside Kubernetes, you can control who has access to them. How you get them in there is kind of up to however you want to work. Okay, so all those 3 YAML files live in the same folder. So I can deploy my secret, my service, and my database pod with one apply command. So that's going to create all those things there. If I look at my services now, I've got my the Kubernetes service is the Kubernetes API. So when things are running in pods, they can access Kubernetes themselves if they need to. I've got my web application, which is this load balancer, so that's publicly available on localhost. And I've got my database pod, which is a cluster IP, so that's only available internally. So again, I've got this cluster IP address, so anytime anything running in a pod tries to do a DNS lookup of bb-bb, it's going to get this IP address back. And when the network gets a request on that IP address, it's going to route it through the VIP to an actual pod, which has got its own IP address. Okay, I should have my pod running too. Oh, see, I've done that again. So I should have my pod running too. Okay, so that's all up and running. If I look at the pod for my database, then there's a whole bunch of stuff which tells me that SQL Server is up and running and everything looks good. Okay, so that's fine. No user action required. Perfect. Okay, so now what I should find is that now that my database has started, my web application is still cycling its container, but at some point the container will start. It will try and connect to my bbdb domain name. The service will answer the request. It will send the request onto the pod that's running my database, and it should just work. So I'm in a crash loop back off, which basically means there's a delay between the restarts. So typically, Kubernetes will try 3 times to restart a container. If it's still failing, it will pause for 30 seconds, and then it'll try 3 times again. And then it will keep extending the amount of time it waits in between the retries so that it doesn't just constantly spin something that's never going to work. The longer it's been not working, the longer Kubernetes will wait before it tries again. So that's what crash loop back off means. It's still there. It will still keep on trying, but it's going to take a little while before it does it. So we've had 7 restarts. It's been sat there for 14 minutes. So it's maybe going to wait for now for, I don't know, for a couple of minutes to see what's going on there. So if I look at my logs, get logs. So just the logs command. I'm still getting that same error command. So this is from the last container restart that happened. And then if I go and look at my pods, ultimately it's going to start again. But at the moment it's dead. So what I will do is I will force it to restart, because the staggering of the loop back off goes kind of incrementally. So it's going to be like 1 minute, 3 minutes, 5 minutes. So rather than we'll all sit here and wait forever, if I kill that pod, delete the pod, and then that's going to start a new pod, which isn't in the crash loop back off stage. So my new pod is started and it's already up and running. So this would have happened if I'd waited long enough, and my crash loop would have resolved, because the next container restart would have found the database and everything would be fine. But if I'm doing a live demo, I want it to be faster, then I can kill the pod and the new pod will be up and running. Okay, so now my whole application is running inside Kubernetes. So I've got services for my web application from the outside world, and pods that will respond to that. And I've got a service internally, a cluster IP service for my database, and a database pod that can respond to that. So those 2 components can talk to each other, and I should be able to send traffic in. Now, this next command is slightly funky, so I'm going to do it piece by piece. So first of all, if I do get service, I can look at the information for my service, which is my external web service. The kubectl command lets you format the output. So if I do kubectl get service and I tell it I want to pass it some JSON path, which is like a query language for JSON, then I can see all the raw data. So JSON is the language that Kubernetes uses, but you use YAML yourself to describe things, and you can get JSON back. So this is the actual data about my object, my service. And because I'm using JSON path, I can craft a query which just gets the bits that I'm interested in. And what this does is it says, here's a JSON path query, get me the address of the load balancer, and then wrap it up in an HTTP string. So what that's going to give me is my HTTP address for my application. And the reason you do that is because different clusters have different ways of showing you the load balancer address. So this nice little bit of JSON path will always get you something that's kind of useful. So if I click on this, here is the application that we saw last week, which is intensely boring, but very simple to run. It's got a bunch of pre-baked data, which lives inside the database. This request is going into my service, my load balancer service. It's getting routed to my pod. The data is coming from my database. If I delete this, it gets actually deleted in the database. I can add a new thing here, so I can do my cube 101. 101 today. And last week I can save that. That now lives in the database. So these things are talking to each other. Everything's kind of working nicely. I can refresh this. It's just going to keep working the same way. Okay, cool. So if I go back to my sites here. Now, the beauty of having a deployment that's running my web application is that it's taking care of the scale for me. So right now, my web application is running a single pod, but I can scale that up pretty simply. I can modify the YAML, and I can change the amount of scale inside my deployment, or I can use the scale command and say I want 3 replicas now. And what Kubernetes does then is it starts up 3 more replicas, 3 more pods, running exactly the same setup. So here's my original pod that's been there for 3 minutes. Here are the 2 new pods that started at the same time 6 seconds ago. They use the same template, so they use the same setup as my original pod. They each got their own IP address, but they're all running the same copy of the app. They're all going to use the same DNS name to get to the database. If I was running on a real production cluster with several nodes, these would be distributed across the nodes. So I would get high availability because it would run, by default, Kubernetes is going to spread things wide across the cluster. So these would each run on a different node, and it would direct the traffic around between them. Because I now have several pods that respond to this label selector, that's the same label selector that's inside the service. So now the service will enroll all of these pods inside its routing table. So if I look at the endpoints for the service, which just shows me the bits, which just shows me the addresses that the service itself uses, then I will get all the endpoints for my pods. So I've got pod 1, pod 2, and pod 3. Because if there are multiple endpoints in the pods, in the service for different pods, then the requests get load balanced around those different pods. So if I go back to my application and I refresh lots of times, so I'm just hitting F5 lots of times, it's going to be shared around all my pods. Again, if it was a cluster with several nodes, exactly the same experience. So I would see the same thing as a user and as an administrator to work with the application, but now these requests would be routed across any node, and whichever node had a pod would be able to respond. Okay, so if I do that now, and now look at the logs. So if you run a logs command for many pods which match the same selector, then you'll get an entry for each pod. So I'm putting the tail option in here to say, get me the most recent log entry for all of the pods that match this selector. So I'm getting 1 from each pod. And we can see these are all log entries that come from Node.js to say that it's doing some work. So each of those pods is doing something. So as I'm sending in requests, it's getting distributed among them all, and everything's kind of working as we expect. Okay, so that's the kind of fast, quick demo. So you've seen services of different types, internal and external. You've seen deployments. You've seen why pods need to be wrapped up in deployments. You've seen why containers get wrapped up in pods. And the last thing is to kind of explain why I had this label of demo on all of my objects. If I do a kubectl get all, which means get me any type of service that has the label demo equals cube 101, and I've got my 2 services. And I've got my 3 deployments. So I've got my database deployment, which is my single database pod. I've got my 3 web pods, and I've got my original sleep pod, my original sleep deployment. Sorry. So the labels I've added are at the top level objects. So the management object, the deployment object, and the services. I can do a delete on all of those objects using the same label. And what I will find then is that it just wipes out everything in my cluster. So the services have been deleted. The deployments have all been deleted, and the pods that are managed by the deployment, they're being terminated now. So because I got rid of the deployments, the deployment owns the pods. So the deployment goes, the pods then get deleted afterwards. So they get kind of garbage collected once the deployment has gone. So if I repeat this again now, let's clear this down. Then I've got nothing running in there. So it's just a nice way to if you're doing demos and stuff, it's a nice way to clear stuff up. And it also shows you how the cascading deletes work. So when you have an object that owns other objects in Kubernetes, if you delete the dependent object, then Kubernetes will start a replacement. But if you delete the owning object, then all the dependents get deleted too. Okay, so that was your super quick introduction. So let me go and open my document here. So I see there's been tons of stuff happening in the chat. So I haven't been dipping into that because I've been trying to get through all this stuff. But I know that Brian's been moderating and picking out some questions. So let's have a look and see what's going on here. Okay, so where are we? Okay, so yeah, there's a whole bunch of questions here. Oh, great. Okay, so oh, there's millions of questions. Okay, that's cool. Let's go and pick some of these out because some of these are pretty interesting. So I'm going to start with how does security get handled when it comes to Kubernetes? So that's Gregor. So thank you for that. So good question. So there are several layers of security. So the first thing is securing access to the resources in your cluster. So the one big difference between Kubernetes and if you're used to working with alternative orchestrators like Docker Swarm is that Kubernetes has role-based access control built in. So it gets kind of complicated, so I'm not going to demo it now. But what you can do is you can say you can split your Kubernetes cluster up logically into different parts, and you can give access to people to specific types of object within specific parts of your Kubernetes cluster, and you can give people different levels of access. So you might have testers who have access to read and list objects, and then you have DevOps people who have access to manage and delete objects. So you get really fine-grained control over who can access your objects, which is the first part of securing your workloads that are running in Kubernetes, because without RBAC, which is the default, so you don't get RBAC by default. It's part of something you set up yourself. Without RBAC, what you find is, sorry, I've lost my thing here. If you've got access to the cluster, you can do anything. So if you've got access to kubectl on your cluster, then you can kind of do anything that you need. The way you give access to Kubernetes to different people is by sharing your configuration setup, which has a bunch of certificates inside it. So you can generate certificates that identify the person, and then within that what they're allowed to do, and you can control the objects they have access to. Within Kubernetes itself, the security side of it kind of depends on what it is you want to do. If you're securing sensitive data, then you use secrets, and there's a whole management layer around secrets, which make it harder to expose that sensitive information. Again, you need to give access to the secret objects themselves, because if people can access your cluster, then they can just go and read the contents of the secret, which is obviously not what you want. But in terms of an attacker coming into your application, the secret will only live in memory inside your container. So they'd have to be able to compromise your application to read the memory to be able to see the value of the secret. Within the cluster itself, it's going to be encrypted in transit, and you can configure your cluster to encrypt those things at rest as well. Okay, why use the more complicated Kubernetes over Docker Compose? Great question. So let me just quickly flip back here. So get rid of my terminal a second. So to run this application, I've got this web deployment YAML, my web service YAML, my database YAML, my database service YAML, my database secret YAML. I described the whole thing last week in Docker Compose. Let me drag this over here with this single YAML file. So I had like 20 lines of YAML in Docker Compose compared to 100 odd that I've got in Kubernetes. The reason you use Kubernetes over Docker Compose is Docker Compose only works on one machine. That's the basic thing you need to get with Docker Compose. Docker Compose is not going to give you high availability across multiple servers. So actually, they're not the two things you would compare. You don't compare Compose and Kubernetes because they're separate things. Like in the real world, you're never going to run a single node Kubernetes server because there's no point in doing that. So similarly, you can't scale up Docker Compose. It's a single server. The comparison really is between Docker Swarm and Kubernetes. Docker Swarm is the orchestration layer that's built into Docker, and it uses the Compose YAML format. So I could take this YAML format here, and I could deploy it to a Docker Swarm cluster, which had maybe a dozen nodes. And in operation, it's very similar to Kubernetes. So the nodes in my Swarm cluster I tell them how many replicas I want of each of my containers, and it makes sure that I get the service level that I want. It can direct network traffic into my containers, all that sort of stuff. There are two reasons why you would prefer Kubernetes over Docker Swarm. The first one is its ubiquity. So Kubernetes is in all the major clouds. Like I can go to Azure, Amazon, or Google, and I can spin up a managed Kubernetes cluster with a couple of clicks or with their command line tool. And most of those, they manage the control plane for you. So Kubernetes has managers that own the API and own looking after all the objects, and then it has nodes that run your application workloads. Most of those clouds, that it's a managed service. They take care of the managers for you. If you want to scale up, you just add another node with a click, and it's there. It's all configured for you. It's all super, and it's integrated with the other parts of the cloud. So when you request certain types of storage in Kubernetes, which you can do, which you can express in your YAML manifest as well, then you'll get an Azure files share in Azure, or you'll get an Azure disk which can move around to wherever the pod needs it to be. So that's the first thing. You can just spin up a managed Kubernetes cluster anywhere, and someone else looks after it for you. Whereas with Swarm, you can't do that. There aren't any managed Docker Swarm options. What you'd have to do is you're going back to IaaS. You're going to spin up a bunch of VMs. You're going to install Docker Swarm and manage it yourself. But it's a very much simpler system to manage, but you're still taking on the management ownership. And the second thing is that although Kubernetes is more complicated, it's more complicated for a reason. Like you can't express all the things you can do in Kubernetes with Compose and Docker Swarm. So the reason why you have this kind of loose coupling between services and pods with this label selector is it allows all sorts of patterns that you can't easily do with Swarm, because it just doesn't have the level of complexity. It doesn't have all the different moving parts. So with this service, because I have a selector to find the pods which belong to the service to send traffic to, that basically is the core feature that lets you do things like blue-green deployments. So I can deploy version 2 of my application and send no traffic in there at all, and then by tweaking my label selector, I can then switch from the new version to the old version and back again. So my pods are already there; they're already warmed up. I just change the selector in my service and send the traffic somewhere else entirely. And then if there's a problem, I roll back. So there's all these extra layers of indirection, unlock a whole bunch of interesting new patterns. So yeah, those are the two reasons. So it's available everywhere. Somebody else will look after it for you, and the reward of the complexity is that you can do all sorts of really cool stuff. So yeah, that's one. Other languages. Can we use other languages like Python as well inside the container? Absolutely. It doesn't matter what's inside your container. Like Kubernetes and Docker don't care. So the only thing that you're going to specify in here is your image, which is your Docker image, and that could have anything in there. So from last week's session, let me go and flip back over here. Last week's section, we looked at the Docker file, which is the syntax you use to package your application. My Node application here is just copying in a bunch of Node.js. I could be starting with a Python image and copying my Python application. My Docker file for my database starts from SQL Server, so this is a completely different type of application stack. Kubernetes doesn't care what's inside your container, as long as it is an OCI compatible format. So if a Docker image that you pull from Docker Hub, you can run anything in there. Okay. Okay, so yeah, I covered that a little bit, but this is a question: what are the advantages of AKS and EKS and GKE over running your own kind of Kubernetes? And it's mostly down to the integration. So one of the reasons why the cloud providers got so interested with Kubernetes was the fact that it integrates with their other products. So I talked about when you deploy a load balancer type of service onto AKS, you're going to get a public IP address. Azure will create you a public IP address. It'll set up some actual real load balancers, and it will send traffic into your nodes. And then Kubernetes takes care of sending it into the pods. The same with storage. Same principle with AWS. It will create a an elastic load balancer service, and it will send the traffic around your pods. It can integrate with S3 to store your data, or with a managed disk, or whatever. So the clouds really like it because it integrates with the rest of their platform, which makes your life as a user so much easier. I haven't covered it, but I've got the smiley face up. Well, I've got the smiley face up. I haven't covered it, but you can define storage requirements in Kubernetes as well. And in the same sort of idea, you define objects that you care about in YAML, and you attach them to your pod, and that will be you can have storage classes defined in your cluster. So I don't care where it is, but just give me some fast SSD storage, or I don't care where it is, but I need something that's replicated so that I can access it from any node. You get all that with your cloud provider. They manage it all for you. So that's the reason why you would have it, rather than kind of running your own. In the high-level diagram, please explain the role and part the node plays. Sorry, yeah, I've probably not been clear about that. So what a node is, let me go back here. All the node is a server, effectively. So each of these servers is a node. Kubernetes just has slightly different terminology. If you're running your own Kubernetes cluster, which I don't necessarily recommend, then you will start off by creating a manager, which is the thing that you talk to, the thing you send your API request into, and then you create nodes, and they join the cluster. And the cluster itself is this collection of servers, and you call the servers nodes. So that's all it is. And then when you're deploying your applications, Kubernetes works out which node is going to ask to run a pod for it. So there's a constant communication between the managers and the nodes to find out, what pods are you running, what health are they in, what status are they in, so that things like deployments can work out if they need to replace pods. But also when you schedule some new work, the manager talks to all the nodes and works out where it's going to ask, which node it's going to ask to run the pod for it. So using things like, how much CPU is available, how much memory is available, how much of those resources are being requested for the pod. So by working that out, then a pod gets scheduled to that node, and it's the node's job then just to run the pod. So the nodes are fairly dumb in the Kubernetes architecture. The managers work out where everything's going to go, and the nodes just run the workloads. Okay. Okay. So good question here from Nuno. What's the major difference between learning locally on a single node to managing a production environment, and what's going to help you make the learning journey? So from an application modeling point of view, if you model your applications correctly, then there isn't a huge difference because the YAML's the same. The objects you're defining are going to be the same. The main difference between your production deployment and your local deployment is going to be like the number of replicas, because in a production deployment you're going to have more resources available, so you're going to run with higher availability, and the actual configuration of your objects. So it's going to be your config map that tells your application what to do, which gets loaded as a config file inside the container, and then the amount of scale you've got. The objects themselves, the definitions themselves, are going to be pretty much the same. The difficulty really is in administering the cluster, which is going to be wildly different depending on where you're running your cluster. So Kubernetes has this idea of a certified platform, and if you meet certain requirements, then your Kubernetes deployment is certified. So Docker Desktop is a certified Kubernetes deployment. So is AKS, so is GKE. Obviously, they're very different, and they have very different ideas about things. But the main differences between your deployments are going to be around the edges, those integrations. So what happens when you deploy a load balancer service in your cluster depends on how your cluster is configured. So with Docker Desktop, I get a local host address. With Azure, I will get an Azure public IP address. So my definition is the same. The YAML is the same. The way I integrate with it, the way I work with it is the same. What's different is how your application is actually going to interface with the rest of the world. Same with storage. So if I request some storage in Docker Desktop, what I'll get is a directory on my virtual machine that gets surfaced inside the container. When I do that on same YAML description, when I deploy that to Azure, I'll get Azure files, and it will write it in cloud storage. So how you get that, obviously, that's a nice way for me to plug my new book. So this is I've only written 3 chapters. Actually, I've written 6 chapters, but only 3 are available right now. You can go and buy this. And I don't know if you're familiar with Manning, but they have this early access program. So as I'm writing the thing, you can be reading the chapters and giving me feedback, which I would really appreciate if you've got any feedback about the stuff that's up there right now. The difficulty with learning Kubernetes that I found, and the reason why I wanted to write the book about it, is Kubernetes is fast and it's changed a lot over the years. But also there are very different approaches to learning it depending on what your background is. So a lot of people will focus on the admin side of it and setting up your cluster and how you connect your servers together and the networking layer and that sort of stuff. Which actually, if you're running in the cloud, you're probably not so interested in that. You're going to leave someone else to work that stuff out, and you're just going to say, "Give me a cluster with 10 nodes." So what this book does is it looks very much from a kind of real world perspective of how do I model my applications to run in Kubernetes? What does it give me that I can take advantage of, and how does all that sort of stuff work? So naturally, I'm going to recommend recommend my own book for that. Okay. Let's have a look at this. So sorry if I don't get to your question. There are a ton of questions here. So I think what I will do is I'll grab these questions afterwards, and I'll stick these. I'll put a blog post together, and I'll answer all the rest of them in the blog post. Okay, so let's just pick out a few more because we got another 15 minutes, assuming that people are staying on. Let's have a look. Oh yeah, so there's still a lot of people there. Okay. All right, so some great questions here. So I'm only going to give hints for some of these answers. So Hussein says, what a Helm chart is used for. And a Helm chart is a way of trying to abstract away the complexity of all your YAML files. So the YAML files that I've got here, these are fairly simple. If I open, let me open another window here, and I'll show you something a bit more relevant to this sort of thing. So even if you're not, I'm not trying to say you shouldn't buy my book, but even if you're not going to buy the book, all the stuff for this book, all the samples I do are all up on GitHub, so you can see this. Chapter 6 that I've just been working through is about different ways of running applications, and as part of that, I've got this really simple to-do list. And inside my to-do list, I've got a bunch of other things that I haven't shown you today. So this is what a configuration file looks like. That gets created as a config map inside Kubernetes. In this case, I've got some flags that are different for different environments. Okay, so that's the first thing, where if I wanted to run this in different environments, I might have different config map files. I've got secrets. Again, those are connection strings that might be different for different things. My ports might be different for different environments. And then if I look at my database, it's way more complicated because this is using a stateful set, because it's got storage attached to it. And if you just look at don't worry about the details, look at the level of complexity that's in this here. Ultimately, I'm running a Postgres container. Like, that's all I want to do. Actually, I want to run two because there are two. But the way this runs, it's a replicated database. So one of these containers will be in a pod that's designated itself as the master or the primary, and the other one will be the secondary. So it's replicating data between them. And the reason I have this example in the book is because Kubernetes lets you do that stuff. It lets you model an older application that has certain expectations about how it works. But if you think about the complexity of all this stuff, there's lots of config here which could be different in different environments. And that's what a Helm chart does. With a Helm chart, basically you wrap up all these YAML files that describe your application. And actually, I would take the database part of it and maybe the web part as well and put it in a single chart. And then you put in placeholders for the things that are going to be different in different environments. So, do I want my configuration web page enabled, true or false? That's going to be a value I can pass to the Helm chart. So I'll use the Helm command line to deploy my application rather than kubectl. I'll use a chart which is available on a public server, and then I can pass it the parameters. Well, I'll do Helm install to do web or to do application, and -- config controller enabled false. So I don't have to dig into the YAML. I don't have to know how my application is configured. I can just use Helm to manage it, and I can use Helm to do upgrades between different versions as well. When you use Helm in real life, kind of depends on how big your Kubernetes usage gets. If you want to deploy a third-party application, lots of teams who run open source projects provide their applications as Helm charts. So you can do a Helm chart of, I don't know, Prometheus and Grafana or something like that. And they take care of the complexity of it. They package it up using the best practices that they think you should use, and so you don't have to write your own YAML files for all that stuff. And the other reason you would use it is if you're running all your applications in Kubernetes and you want to have a nice consistent way for operators to deploy and manage your apps without them having to dig into all the YAML, then Helm is a layer on top of that. It just makes it easier to abstract away the details of the YAML, just focus on the bits that are different for each environment, and then you don't have to share your 500 lines of YAML with someone to be able to deploy your application. Okay. Okay. If your pods. Oh, okay. Good one. This is from Ashoka. If your pods are individual microservices in a larger system and you need centralized logs, how does Kubernetes facilitate that? So, out of the box, it doesn't give you centralized logs, but there are, Kubernetes is in container years, it's a very old established system, and there are patterns for all of this stuff. So the way you do this is that you run a pod on every node. Kubernetes has a mechanism to say, I want to run a replica on every node, rather, not just run 10 replicas anywhere, one on each node. That pod is going to run an application like FluentD, and what FluentD does is it scrapes up the container logs from that pod. So as each pod is writing its own log entries on the node, there's another pod that's scraping them all up, and then it sends them to something like Elasticsearch. And that's an established pattern where you would have like uh, there's another way of deploying applications called an operator, and you might have an operator that says, right, this deployment is going to give me a FluentD pod on each node that scrapes up the logs. It's going to give me Elasticsearch running, which is going to be the destination, the target for all of those logs, and then Kibana, which is my UI, which I can use to search the logs. And that's a fairly established way of doing that sort of stuff, which has the huge benefit that it's a system where the collection of the logs is kind of independent of how many pods you're running. So as you're scaling your application and doing upgrades and all that sort of stuff, pods will come and go. But it's nice to have the historical set of logs, and that system gives you that. So the FluentD collector is scraping up all the logs for all the pods, sending them onto Elasticsearch, and then you can query them and find, historical ones, current ones, whatever you need to do. Okay. Okay, great question. So this is from Mitch. So while devs are working with Docker Compose, who is preparing the Kubernetes YAML files? Is it the ops team, or what is the best approach? Great question. This is one of the sticking points as people move to Kubernetes. One of the great things about containers is when they came along is that the artifacts to deploy and manage your app suddenly became something that everyone worked on. So not like the old days where you had a Word document that said install this version of the operating system and this web server and all these dependencies, and then click all these buttons. Like, that all went away and it got replaced with the Docker file. And the Docker file lives in source code along with your application, and it can be jointly owned by whoever's on that DevOps spectrum. So maybe the devs will write this kind of initial version, and then someone from security will come in and replace this Docker Hub image with a golden image of their own preference that's been hardened. Ops team will come in and add some stuff to give you the metrics, all that sort of stuff. It's kind of jointly owned. And the same with the Docker Compose file. So the Compose file that says when I run my application, I'm going to have my database container and my web container. They're going to connect to the same virtual network. It's pretty simple. Like, so you could be at any point on that team, whether you're the architect or junior or ops or whatever. You learn this syntax. It's pretty simple. You do Docker Compose up and you're ready to go. When you switch over to the world of Kubernetes, it's just not so simple anymore. Suddenly you're dealing with all this sort of stuff, and that's a decision that you kind of need to make. What tends to happen in larger companies is that maybe the devs stop at the Docker file and the Compose file, and then another team will, and they might, when I say the devs, that might be teams who are working on specific components within a larger application. So they'll get their component to work, and there might be mandated that their component has to have a certain expected interface. So it should write logs to standard out, and it should have a /metrics HTTP endpoint where I can get the metrics, and it should do this if it fails, and it should have a way of checking that the application is healthy. All those sorts of kind of loose requirements that you say you can use whatever language you like, but your container image should be able to respond in this way. And then another team will compile everything together. So they'll say, there's our product API, which the team wrote in Python, and here's our web front end that's written in Node.js, and here's our catalog API, which is written in .NET Core. And I've got Docker images for all of those. And now some other team, which I've deliberately not named, will then write the Kubernetes manifest that compile it all together. Obviously, that only works for large enough organizations, and smaller organizations, you're going to find that Kubernetes just kind of works its way down, because you don't. Part of the promise of moving to containers is that every environment is the same. So when I run it in dev, I shouldn't have any big differences between that and my production experience. But I will do if I'm doing Docker run and I run a single container, and in production I'm running on a Kubernetes cluster, because there's way more stuff in between. Doesn't matter if my container works nicely if my service is incorrectly configured in my Kubernetes YAML manifest. So you're by isolating the Kubernetes knowledge, you're increasing the risk that there are gaps between environments, and that's where problems find that are difficult to track down. So certainly for smaller environments, you will find that Kubernetes kind of leaks its way downwards, and the cost of having to learn this stuff is you get the entrance fee to be able to run this anywhere. So you can move to any team. Like if you're a Kubernetes person and you come and pick up my to-do web application, you don't need to know anything about the web application. You can read these YAML files and go, yeah, okay, so I see there's a config map in there. There's a service which is a load balancer, so that's public. I've got my database. There's a secret there for the password. I've got my service, which is cluster IP. I know nothing about this application, but I know I can do kubectl apply, and I'll have a database pod with a service and a web pod with the service, and I can use it that way. So it's a lot to learn, but it's more and more applications are going to be running on Kubernetes, and so it's something that you kind of just need to pick up. Okay, so what are the best practices when using Kubernetes? Okay, yeah. So there aren't. I don't have like 3 best practices to shoot at you. I would say that like at the very broadest level, and people have different opinions about this, but at the very broadest level, I like to keep my YAML definitions as broad as possible so that they work in every environment. So that the difference between my deployment to production and my deployment to every other environment is literally maybe the config map. So the configuration between each environment is going to be different because the app behaves differently in each environment. But otherwise, I should be able to take the same set of YAML manifests and apply them to each environment so that I'm minimizing the differences between them. So that's a kind of a general best practice. And then the other best practices are really around how you use the thing, which depends very much on different companies. So your cluster is either a shared resource which you give to various different teams for various different products, or you have several different clusters. Either of those has difficulties. So managing multiple clusters gets to be a real headache, but at least you have isolation between teams. Whereas managing a single cluster, you've got one set of resources, and you need to be careful who can access what. So the best practices really around using your clusters are you need to investigate RBAC, so you need to have access control, which is nailed down to what people can do, and you're going to be using namespaces. So the idea of a namespace is this way to kind of logically slice up your cluster to say that I've got one cluster with 100 nodes, but actually what I'm going to do is create a namespace for the product API, and the DevOps team who work on that product API, they can do whatever they want in that namespace. They can create objects and delete objects and get the logs. But that namespace itself is limited to, I don't know, 100 CPU cores and 10 gig of RAM or whatever. I can put limits around what the namespace can do, and I can put limits around what people can do within that namespace. So treat your cluster as the runtime environment for everything, and make sure it's being managed properly. Okay, I think we've got time for maybe just one more. Sorry, I've got 31 questions here. I'm trying to scan through to find something that will be entertaining to talk about. Okay, cool. Okay, so I'm gonna. There's two more. There's two more I'm gonna answer here. So Liam says, are you able to monitor the resources across the pods to see how much compute I'm using when apps don't start up? It's kind of the other way around. So inside your YAML manifest for your pod specification, you can put limits on how much a pod should have. Now, I haven't done it in my demos, but you should do that as a best practice, because then it stops your pod going crazy, either because it's being abused or because it's doing something that there's a bug in there, and starving the rest of the node of compute power. So you can put limits on how much CPU and how much memory each pod should have, which we should always do. And that's going to give you that kind of thing. And the rest of it about monitoring is, well, then you're in the world of kind of containerized monitoring, where you're going to be doing things like running Prometheus and having Grafana dashboards. If you are, let's get, I've probably got time for another plug. if you are a Pluralsight user, I did a whole course on monitoring containerized health with Docker. And this talks all about how that stuff looks, how it looks when you've got lots of containers that are running, and how you get the metrics out of them in a dynamic environment, all that sort of stuff. So if you check that out, that's about Docker, but the principles are all the same, and you'll do the same thing in Kubernetes. You'll be running Prometheus to collect metrics, and then you'll be showing them in a nice friendly dashboard. And another one from Nuno, because this is close to my heart. How hard is it to bring a Windows node in order to run Kubernetes Windows apps? So the people have different views about Kubernetes, and there's people who view it as the platform for the future, for your microservices, for running serverless approaches, which you can bolt on top of Kubernetes, and that you don't need to use Docker files, you don't need to build Docker images. You can have a platform that kind of abstracts all that away for you, which is great, right? That's a nice idea. But I like the other view of it, which is it should be the platform where you can run everything. Like if you want to move all of your apps to the cloud, then moving them to Kubernetes is a great kind of first step, which means I will need to be building Docker images, and I will need to write Docker files, because I'm taking 10 or 20-year-old applications and I want to run them in Kubernetes and Azure. Then I've got I can't just throw them at some kind of PaaS system which will automatically run them for me. There are lots of weird tweaks that I need to put into my setup, and the Docker file lets you do that. And that's what I really like about Kubernetes, and the fact that now Windows nodes went GA in Kubernetes last year, and they've gone GA now in all the major clouds. So I can spin up an AKS or an EKS or a GKE cluster. They all have Windows node support. So in terms of a managed experience, like, it's super simple. I go to my Azure portal, or use the command line, and I say I want a new cluster and I want 10 nodes, and 5 of them should be Windows. So that's super simple. And in terms of the management side of it, that's pretty simple too. So you're going to have, as part of your pod definition, you will have effectively a way of selecting the node that you want to run on. So you kind of specify that in broad terms, I'm a Windows app, so I can only run on a Windows node. But from a management experience, when I do kubectl get nodes, I will see all of my nodes. The containers that are running inside those pods, they can access each other, whether they're Windows or Linux. The DNS spans the entire cluster. The virtual network that Kubernetes gives you spans the entire cluster. I'm still doing the same, the same management aspect with kubectl. If you're doing it yourself, and you're not in a managed environment, then it's a bit harder. So I wrote a blog about this a little while ago, which I think is out of date now. But if you check out this tells you there's a bunch of scripts in a GitHub repo that show you how this works, and you use a tool called kubeadmin, which you use to create your cluster, to start the managers, and add other nodes to it. So you can walk through this. It needs updating, I think, because this is using 115. So we're on 118 of Kubernetes now, and it's got better all the time. The big advantage of Kubernetes is that all this stuff happens in the open. So there are special interest groups for all the areas of Kubernetes, and there's a SIG Windows special interest group for Windows. They have like weekly meetings that are on Zoom that you can join in with. They have a Slack channel that you can go and join in with. All the stuff they're doing is up in public repo, so you can follow it along with that. So yeah, you can kind of track that stuff down. So the quick answer is, if you're in a managed environment, it's super easy, and if you're not in a managed environment, it isn't. Okay, and so one last one from Gregor, who says he's new to Kubernetes and this looks incredibly complex. Yes, you are right. How do you go about tracking logs across pods and stuff like that? Well, because Kubernetes owns these objects for you, it manages them for you. You are not going to do things like get me the logs of this particular pod, because you're not going to know the pod name, because Kubernetes will find that out for you, which is where all the kind of service labels come in. So the label selectors are how you interface with most. Oh, that's the wrong window. How you interface with most of these things. So let's go and open this back up. So my README file here. Let's got all the cheats. So the way you're going to work to answer that specific question, the way you get your logs is by using a label. So you're going to say, get me the logs for any pod that has this particular label, and the similar things that if you want to execute a command and connect to a pod, and there are several of them, then kubectl exec is just going to pick the first pod in the deployment. So there are lots of kind of subtleties that if you're used to working with Docker and with Compose and with Swarm, Kubernetes is quite different about that. But the thing to remember is it's very much more complex, but the more you get into it, the more you like it. So there's this pattern that repeats when you're learning Kubernetes and when you're helping other people learn Kubernetes. It's like, wow, like this is so complicated. Why is this so complicated? And then a few steps later down, you go, wow, yes, you can do that. That's fantastic. So services being a really, really clean example. So there's no real notion of a service in Docker Compose or Swarm. It's just that if your containers publish a port, then you can send traffic to them wherever they are. That by having an explicit service in Kubernetes, it enables you to do different things like have internal or external services. And by having the selector, it enables you to send traffic to different places and do kind of smart deployment things. So quick example there, that the complexity isn't just there for fun. The complexity is there because it's massively powerful, and you can do some really, really cool stuff. Okay, so Brian tells me that I need to give the names of 4 Q&A winners. So let's go back to that list. So the questions that I liked best, let me see. Can't remember which ones I answered now. Let me know which ones were best. So Brian, why don't I go through and I'll do the numbers. I'll do the numbers of the question. I should have highlighted the ones I answered. Also, Rodrigo says, what are the differences between Kubernetes and OpenShift? Well, I cannot tell you because OpenShift is Red Hat's version of Kubernetes. It's a certified Kubernetes deployment. So, in theory, all the YAML files you write for other systems will work on OpenShift as well, but it bolts a whole bunch of stuff on top. So, the big things with Kubernetes are making your app work on Kubernetes and then understanding the best way to get to get what you want from your own Kubernetes deployment. So, things like AKS and GKE are fairly standard. They integrate with storage on the cloud side and with networking, but I think things like OpenShift are a little bit more custom. Okay, I can't remember the questions I answered, Brian. So what I will do is I'll go through and I'll send Brian the list afterwards. The people who are going to win the copy of my book. So yeah, as I said, this is available now in early access. I'm just finishing up chapter 6 right now, so you will get chapter 6 at some point. And I'm hoping to get it written by August. So I've got quite a few chapters to write yet, but it's all kind of specced out. I know how it's going to look. One thing if you do get this, there's this kind of comments forum that you can put stuff in. I would really appreciate telling me if the chapters are too long, because this is like the sequel to my other book, Learn Docker in a Month of Lunches. And Docker is very much easier to teach because the topics are quite nicely defined, and you can, like, you're not just telling the topic, you're showing people how to use it and why it's important and what you get out of it and that sort of stuff. I'm trying to do the same thing with all the Kubernetes topics. But there's so much that you just can't leave chunks out because you wouldn't be doing a proper job of teaching it. So if you do grab this book, then please let me know through the forum or through any other forum whether you think they're too long or whether you think I should be kind of trimming these things down. So yeah, that's about that. So thank you very much again for joining. Let me switch back to my where are we? Let's do this button here. So here I am again. So yeah, thanks very much for joining. I hope you found that useful. I know there's a ton of stuff there, and I promise you we have barely scratched the surface. And even to scratch the surface, we've gone into a level of complexity because like there's no point showing you anything else. Like I could have just done a kubectl run command and that would have started an app in a pod, but then like you wouldn't ever do that in reality. So the reason I've gone through the YAML and the service objects and the deployment objects and giving you that kind of map of how these things fit together is so that you've got a decent place to start from. So yeah, I hope that was useful. Thanks very much again, Brian, for hosting it all. The recording of this will be available at the same URL. So if you want to pick that up, then feel free. I will look out for me on Twitter. I will do a blog post with the answers to all the questions. And thanks very much for joining in. And check out Brian too at Linuxing in London, because I think he's going to publish a YouTube channel soon with all his content coming through, and that should be great too. So thanks very much for joining us. I hope it was useful, and hopefully I'll see you again. Thanks.